Word instruction is stored in memory at an address designated by symbol W. The address field of the instruction stored at W+1 is designated by symbol Y. The operand used during the execution of the instruction is stored at an address symbolized by Z. Z is the address of the operand, that is effective address. Which of the following is /r correct if the addressing mode used is the relative addressing mode? So here, according to the given data, there is a two-word instruction. The first instruction, that is two-word instruction, is stored in memory at an address designated by symbol W. And then that instruction contain opcode as well as address. The address field is at W+1. So this is opcode followed by address part. Address part is W+1 and this is symbolized by Y. So Y is nothing but W+1, both are same. Instead of saying W+1, we are saying it is Y because that is symbolized by Y. And then the operand used during the execution of the instruction is stored at an address symbolized by Z. Z means effective address here because operand address is effective address. So operand address is Z. Which of the following is / are correct if addressing mode used is the relative addressing mode? In the case of relative addressing mode, effective address is equal to program counter plus address part of instruction. What is address part of instruction? Program counter, you know. For example, if you are executing current instruction, it will point to the next instruction. So here the next instruction will be here, that is at W+2. it is same as Y+1. Immediately after W+1 address, we used to have the next instruction. So the PC value is W+2, or else we can write it as Y+1 also. Plus the address part of instruction is what? Content of memory at address Y is nothing but address part of instruction. So that is M of Y. Address part of instruction is there in the memory at address W+1. That is nothing but Y only. So now W+2 plus M of Y, Z is equal to that value. Or else in the form of Y, if you want to write, we can say that it is instead of saying W+2, we can say that it is Y+1 plus M of Y. So W+2 plus M of Y is there in the option B, and Y+1 plus M of Y is there in the option A. So both A and B are correct. Option D is the correct here because one or more may be possible here, because which of the following statement is /r correct? That's why both A and B are correct. D is the right option here.
20 kbps device is connected to the processor. The interrupt overhead is 10 microseconds. What is the minimum performance achieved when interrupt initiated data transfer is used instead of programmed input output? Here data transfer rate of device is given as 1 second 20 kilobytes. So what is the time taken for 1 byte? It will be getting as 50 microseconds. So program driven input output would be 1 by 50. Here interrupt overhead is given as interrupt overhead is given as 10 microseconds. That means interrupt driven input output would be 1 by 10 microseconds. This is microseconds. So performance would be performance is equal to interrupt driven by program driven. Interrupt driven is 1 by 10 divided by 1 by 50. This is nothing but 50 by 10, which is 5. Your correct option is option B. A hardest NP problem X is reduced to problem Y in a polynomial time. All the problems in NP are reduced to problem X. Then which of the following statements are true? First statement, S1, X is NP complete and Y is NP. S2, X is NP complete and Y is NP hard. And S3, X and Y are NP complete. S4, X and Y are NP hard, hence they are NP complete. Here it is given that X is NP, X is NP, X is in NP, and all the NP problems are reduced to X. That means we can say X is NP complete. And also it is given that problem X, that is NP complete problem X, is reduced to some problem Y in a polynomial time. That means if any known NP complete problem is reduced to some other problem, then that problem is also NP complete. So we can say, as here X is NP complete. Why? Because here X is in NP and all the problems in NP are reduced to X. So we can say X is NP complete. As known NP problem X is reduced to some problem Y in a polynomial time, we can say Y is also NP complete. So we can say S3 is X and Y are NP complete. This statement is true. As Y is NP complete, Y is also NP hard. All the NP complete problems are also NP hard, and the NP hard problem may or may not be NP. So here we can say statement S1 is false. Why? Because it is given that X is NP complete and Y is NP. Y may or may not be NP. So we can eliminate S1. S2, X is NP complete, Y is NP hard. This is true. Why? Because Y is NP complete, so it is also NP hard. So statement S2 is true, and statement S3, X and Y are NP complete. This is also true. X and Y are NP hard, hence they are NP complete. This is false. Why? Because if a problem is NP hard, it may or may not be NP complete. So here correct option is option A.